Okay, so back to 22. So what I have here is that we are 570 feet off the ground with an angle of depression of 26 degrees. It says it sees a Mexican army from an angle of depression of 43 degrees, and it would be the same height from this here tower. So the question is, how far apart are the two armies? So we're going to have X here, and another X here, and then we're going to add them together. So to solve this one, I have opposite over adjacent. So that's tan 26 equals 570 over 26. No, just kidding, over X. So that means I'm going to divide 570 divided by tan 26. So that leaves me the number 1168.7. I'm going to do the same thing here. Also tan, opposite over adjacent. So tan 43 equals opposite over adjacent. So 570 divided by tan 43 is the number 611.25. So now I'm going to add these numbers together. And that gives me the number 1779.9. Using the information from the previous problem, if there are reinforcements coming in from the west at an angle of elevation of 37, how apart are they? Okay, so here's 37, here's the west, here's the height of the building. Again, it's tan, opposite over adjacent. So tan of 570, no. Tan of your angle equals 570, opposite over adjacent. That leaves me with 756.4. All right, at the bottom of this page here, we're going back to trig, not trig, special right triangles. So we have 30, 60, 90. Their pattern is x, x root 3, 2x. Then we have 45, 45, 90. Its pattern is x, x, x root 2. So in this first one here, we have a 45. So I'm going to set that triangle up. 45, 45, 90, x, x, x root 2. So it says that the x is the number across from the 45. So that's the number 5 root 2, which means this x also has to be 5 root 2. So now this one is x, which is 5 root 2, and then another root 2 behind it. Root 2 times root 2 is root 4. Root 4 is 2. 5 times 2 is 10. So the side across from my 90 is the number 10. Another one. These are all the hardest ones, of course. 30, 60, 90, x, x root 3, 2x. I have the 60, across from it is the number 9. So I make an equation that says the x root 3 side is the number 9. We solve for x by dividing by the square root of 3. I can't have a square root of 3 on the bottom, so it's called rationalizing the denominator. So the top becomes 9 root 3. The bottom becomes root 3 is root 9. Square root of 9 is 3. This divides, 9 divided by 3 is the number 3 root 3. Then the side across the 90 takes this x value and it doubles it, so that becomes 6 root 3. It's asking for a, which is across from the 90, which is 6 root 3. Last but not least, these are so difficult. 45, 45, 90. X root 2. The side across the 90 is a 17 root 6. So what it's saying is that the x root 2 side is across from 17 root 6. To solve for x, we divide. It's called rationalizing the denominator, root 2 over root 2. So it's 17 root 12 over 2. Difficult question. Okay, let's flip one last page. Whole page of trig. Of special right triangles. 27. $30, $60, $90. X root 3, 2x. We have a side across the 60. It's the number 7. So I make an equation. X root 3 equals 7. I get x by itself by dividing root 3. To get rid of the square root in the denominator, we give them both the root 3. Root 3 times root 3 is root 9. Square root of 9 is just 3. Then we double that. It only doubles the very front number, which makes it 14 root 3 over 3. The question is A. A is across from the 30. The one across from the 30 is 7 root 3 over 3. Okay, this is a 45, 45, 90, because it has two sides of the same, which means the two angles also have to be the same. The side across the 90 is the number 13. Get x by itself. Get rid of the root 2. That leaves me with 13 root 2 over 2. This one here is Pythagorean theorem. We've got two sides of a right triangle, so I can solve for the third side. So the leg plus the other leg equals the hypotenuse. We solve. And we take the square root. Okay, I'm going to set you up with these, and you can finish solving them. 30, 60, 90, x root 3, 2x. The side across the 30 is a 3 root 2, which means this is going to be 3 root 2 times root 3. This is 6 root 2. Multiply those together, it becomes 3 root 6. Another 45, 45, 90. The side across the 90 is 14 root 5. So you set up your equation. You rationalize our denominator, and the answer is 14 root 10 over 2, which reduces to 7 root 10. These last two here, this requires the Pythagorean theorem, 16 squared plus 12 squared. Square root of that is the number 20. So if that's 20, I'm going to take a special right triangle. And I'm going to say that the side across the 90 in this triangle is the number 20. I can solve for x. X root 2 is 20. And we get x by itself. That leaves me with 10 root 2. Okay, so try the same thing with number 33.